Welcome students, I am Muhammad Naveed and you are watching my YouTube channel. In this lecture, we shall find how to find the area of the region that is inside the circle r equal to 5 sin theta and outside the limacon r equal to 2 plus sine of theta. The first curve is r equal to 5 sin theta. If we compare with the equation of circle with center at y-axis, that is r equal to 2a sin theta. So here we get a equal to 5 by 2. So the radius of this circle is 5 by 2 means 2.5 and with center at y-axis, positive y-axis. Our second curve is r equal to 2 plus sine theta. This is a limacon. If we compare this with general equation of limacon, r equal to a plus b sine of theta. Here a upon b is equal to 2 upon 1, which is equal to 2. So the second curve is a convex limacon which looks like a circle, which is almost a circle. So we have to find the area which is inside the circle r equal to 5 sin theta and outside the limacon r equal to 2 plus sine of theta. So we have to find the area of the shaded region as shown in the figure. First we find the point of intersection of these two curves. For point of intersection, we compare these two equations. The first equation is 5 sin theta and the second equation is 2 plus sine of theta, 2 plus sine theta. When we compare these two equations, we get the point of intersection of these two curves, which implies 5 sin theta minus sine theta is equal to 2, which implies 4 sin theta is equal to 2, which implies sin theta is equal to 1 upon 2 and theta is equal to sine inverse of 1 upon 2, which implies theta is equal to, as we know that sine inverse of 1 upon 2 is pi by 6. This is our principal angle, and as the value of sine is positive in first and second quadrant, so in second quadrant our angle becomes pi minus pi by 6, which is 5 pi by 6. So we have two points of intersection, one is pi by 6 and the second one is 5 pi by 6. So the point of intersection is pi by 6 and 5 pi by 6. This is our angle pi by 6 and the second one is 5 pi by 6 in second quadrant. Now we have found the point of intersection. Now we find the required region which is bounded by two curves. We use the formula area equal to integration, definite integration from alpha to beta 1 by 2 r square and d theta. So in this case our region is symmetrical about y-axis. So first we find the region in first quadrant and multiply this region by 2 to find the whole region, as the region is symmetrical about y axis. So our required area is equal to definite integral, as in first quadrant our theta varies from pi by 6 to pi by 2, pi by 6 to pi by 2, 1 by 2. Our outer curve is 5 sin theta and inner curve is 2 plus sin theta. So we can write it as 5 sin theta whole square minus 2 plus sin theta whole square d theta, and we multiply it by 2 as this region is symmetrical about y axis. Now we solve this definite integral to find a required area. This is equal to 2 times, here 2 is cancelled out. So we get area is equal to definite integral from pi by 6 to pi by 2. 5 sin theta whole square is equal to 25 sin square theta minus, we open this square, this is equal to 4, 2 square equal to 4 plus sin square theta plus 4 sin theta whole d theta. This is equal to definite integral from pi by 6 to pi by 2, 25 sin square theta minus 4 minus sin square theta minus 4 sin theta whole d theta. This is equal to definite integral from pi by 6 to pi by 2, 25 sin square theta minus sin square theta is 24 sin square theta minus 4 sin theta minus 4 d theta. Now this is equal to definite integral from pi by 6 to pi by 2, 24 sin square theta d theta minus definite integral from pi by 6 to pi by 2, 4 sin theta d theta minus integral from pi by 6 to pi by 2, 4 d theta. Now this becomes integral from pi by 6 to pi by 2. 24 is constant, so we take this outside this definite integral. Sin square theta d theta minus 4 pi by 6 to pi by 2 sin theta d theta minus 4 and definite integral from pi by 6 to pi by 2 d theta. In next step it becomes 24 integration pi by 6 to pi by 2 sin square theta can be written as 1 minus cos of 2 theta upon 2 d theta minus 4 integration pi by 6 to pi by 2 sin theta d theta minus 4 integration pi by 6 to pi by 2 d theta. In next step we can write it as 2 and 24 is cancel out here and we get 12 definite integral from pi by 6 to pi by 2 d theta 1 d theta minus definite integral from pi by 6 to pi by 2 cos of 2 theta d theta minus 4 time integration pi by 6 to pi by 2 sin theta d theta minus 4 time integration pi by 6 to pi by 2 d theta. Now we apply the integration. So here 12 is taken as common from these two terms. So here we use bracket. Now it becomes 12 times as integration d theta is equal to theta and theta varies from pi by 6 to pi by 2 minus integration cos 2 theta is equal to sin 2 theta upon 2 and theta varies from pi by 6 to pi by 2 minus 4 times integration sin theta is equal to minus cos theta minus cos of theta and theta varies from pi by 6 to pi by 2 and the last term is 4 integration d theta is theta and theta varies from pi by 6 to pi by 2. Now this is equal to 12 variation of theta is from pi by 6 to pi by 2. We can write it as pi by 2 minus pi by 6 here 12 is common from these two terms. Now the second integral becomes minus sin 2 pi by 2 which is sin pi by 2 minus when theta is pi by 6 so 2 theta becomes pi by 3 sin pi by 3 divided by 2 plus 4 it becomes cos pi by 2 minus cos pi by 6 cos pi by 6 minus 4 times pi by 2 minus pi by 6